Mr. Davies' dose of science. If this is your first time learning with us, welcome. If not, welcome back. Hello everyone, it's Mr. Davies back with your dose of science. For today in science, we're going to be sort of putting it all together. So far this week we spoke about the difference between weight and mass, and we spoke about volume. So now we're going to put mass and volume together to figure out what density really is. To do that, we're going to use Canvas. We'll look at your packet, about 4 pages in your packet. So in order to get started, we're going to pull up, well, let's start with the web page. It's always a good place to start. I've tried to keep this as a go-to spot so you can get to whatever you need if you go here first. And by participating and completing your activities, I think you're doing well. If you need a shortcut to get to Canvas, click the word here and selecting your block, and all of your resources are right here. So your packet is the PDF document, density, mass, volume. You do not need to print it. You can just look at it digitally. If you want to do the activities, you can. They're great practice. Certainly check out these videos if you have not already. Taking a look in your packet, the first few pages are all about vocabulary words. We realize that vocabulary is super important because that's what allows you to express yourself and reflect on what you've been learning in an intelligent way. The pages for density start on page 14, and I believe there's 4 pages. As we read this section, you should find out what density means. Look for examples of things in our world that have different densities. By the end of the lesson, you should be able to explain what must be true about the density of an object if it floats in water and also if it sinks. Density is a calculated measurement. So this section is entitled Calculating Density. Density is a measure of how tightly mass is packed into the space it takes up. What happens if you put a bottle of water into the freezer? The water expands. If it is in a glass bottle, the newly formed ice may actually break the glass. Why does this happen? When the water freezes, it takes up more space. It becomes less dense. Ice floats in water for this reason. Density can be determined by using a ratio. A ratio is a comparison often expressed as a fraction or a decimal. Density is the ratio between an object's mass and volume. Density is equal to mass divided by volume. Let's look at this example. Say you have 100 grams of water. Its volume is 100 milliliters. So its density is 100 grams divided by 100 milliliters, which is equal to 1 0.010 grams per milliliter. If you freeze that same 100 grams of water, its volume will increase by about 9%. The density of ice is 100 grams divided by 109 milliliters, or 9200th grams per milliliter, which is less than 1. Iceberg. Knowing the density of ice can tell us the size of a floating iceberg. An iceberg can present a hazard to ships because only 1/10 of it is above water. This is because of the small difference in the densities of ice and seawater. Comparing their densities results in a ratio of 9/10, the amount of an iceberg that is under the water. Incidentally, the Titanic ran into an iceberg on its first maiden voyage across the Atlantic Ocean. The Titanic sank April 14th or 15th, 1912. So that would be what, 108 years ago? Certainly something we should learn from. Density can often be used to identify an object. For example, it can be difficult to see the difference between gold and other shiny yellow metals. Measuring the density of a metal can help you determine what it is. But density cannot be measured directly. It is what scientists call a derived measurement. It comes from two distinct direct measurements: mass and volume. When two of the terms are known, it's easy to find the third one. Look at this magic circle to the right. Cover up the term you want to find. For example, to find the density of an object, when its mass and volume are known, you cover up density. What's left is mass divided by volume. This tells you to divide the mass by the volume to find the density. To find the mass, multiply the density times the volume. And to find the volume, the mass divided by the density. Here's an interesting story, it's historic in nature, about density. Archimedes and the king's crown. Knowing how to find density can be very useful. The first person to understand this was Archimedes. He was one of the best mathematicians in the ancient world. Over 2,000 years ago, a Greek king came to Archimedes with a problem. He had ordered a crown made of gold, but he suspected that the goldsmith had only put gold on the outside of the crown, stealing the rest of it. The king wanted Archimedes to find out if the crown was made of pure gold. At first, Archimedes was not sure how to answer the king. Then one day, while taking a bath, he discovered the answer. Archimedes noticed that the water level rose as he sat down in the tub. Archimedes measured the mass of the crown. Then he measured out the same amount of gold in the form of a bar. He placed the crown on one side of a balance and the gold on the other. He then lowered the two objects into a tub of water. If the crown were made of pure gold, the two masses would have the same volume and density. They would balance. If they did not balance, then their volumes and densities must be different. Sure enough, the pure gold was more dense than the crown. The goldsmith had tried to cheat the king. He had made the crown equal to the mass of the gold the king had given him, but he did not know that the volume had to be the same as well. Which two measurements did Archimedes need to know in order to calculate the density of the crown? And why does ice float in water? Incidentally, one important fact that you should realize: fresh water has a density of 1 0/100, exactly 1. So any item that is less than 1 would float in fresh water. And any item that has a density greater than 1 will sink in fresh water. Okay. So last night when I was sitting here trying to figure out how to make this easier for you guys to remember and understand, I just wanted to emphasize that all this is a relationship between the mass of an object and how much space it takes up. So if you have an increasing amount of mass or more mass and less volume, then you're going to have more density. If you have less mass and you have more volume, then that's less density. Also made me think about a video that we saw quite a while ago, at least a small clip from that video, where a person was demonstrating two items of a similar size or a similar volume and definitely to different masses. I'm going to go ahead and play that clip right now, and I think you'll be able to tell which one was more dense or had more stuff in it.
And the amount of material is called mass.
These two things look about the same size, a pillow and a bag of wheat. Now the pillow is mostly air, so it's easy to move. The bag of wheat's got a lot more material in it, has a lot more stuff, so it's harder to move. It has more mass. This shows us that size and mass are not the same thing.
Yeah, you could tell just when he patted his hand on that bag of wheat. A lot more dense than the pillow. We're going to be starting a unit on living things. And part of that unit is going to be to create a terrarium. So it's probably a good idea if you start collecting those materials now, or at least keep your eyes open so if you run across them, you can set them aside. One thing you will need is a 2-liter bottle. So whoever runs your household, maybe even you, if you take the recycling out, grab a 2-liter bottle. You just need an empty with the cap, okay? Honestly, a clear bottle works best, but if you have one that's green, that'll work too. Always try for one that's a straight bottle, but I've used the ones with the hourglass and it works out fine. Okay, so either one, grab a 2-liter bottle. That will definitely be necessary. You're also going to need access to some dirt. I happen to have some potting soil laying around. That's what I'll be using, but you're going to need some dirt. So if you have some in a shed somewhere, set that aside. You don't need much, only about 2 handfuls. Along with that, some type of seeds. Now, a lot of people think, oh, well, I need to have grass seeds, and certainly that will work. If you have some laying around, you can toss some in there. But other things will also work, like field corn, even popcorn, or a regular soup mix of beans, okay? That certainly works easily. So you might have these in a cupboard. You don't need the whole thing. Only 3 or 4 will do, okay? And you don't need these next week. You don't have to go out and buy anything. Oh my gosh, please do not do that. Just take a look around at what you already have, and something will probably be very useful. Set it aside, and in about 2 weeks, we'll go through how to do that. It's a great way to track growth over the year. If you have a garden outside, we could also use that as well. Stay healthy. Stay safe. Until next time, this is Mr. Davies. Have a great weekend. If you learned something today, please like this video. If you think there is more you can learn, then click subscribe or consider coming back again tomorrow. The information, likenesses, and opinions in this video are the intellectual property of Mr. Mike Davies. While Mr. Davies does refer to other works owned by others, those resources are either parts of a public school district curriculum or they are readily available through open forums on the internet. Mr. Davies does offer his thanks and appreciation to any entity he has chosen to refer to or gather sound bites or clips from to emphasize his lessons. Mr. Davies is currently a professional member of the teaching staff for Central Dauphin School District in Harrisburg, Pennsylvania, and is making, producing, and publishing these videos for the benefit of his students and other students during the current lockdown crisis. Mr. Davies does not make claim to all of the ideas and resources referenced in his videos. However, he does claim responsibility and rights to his likeness, opinions, and the academic content of these videos. He does not grant permission for any entity to copy or duplicate any portion of this video or any of his videos for private or personal gain.